What are the compliance rules for anti-islanding in electrical grid-tied systems? Have you ever wondered how electrical systems ensure safety when it comes to renewable energy? Today, we will discuss the compliance rules for anti-islanding in grid-tied systems. This is a vital topic for anyone interested in power systems and renewable energy. First, let's clarify what islanding means. Islanding occurs when a part of the electrical grid continues to receive power from local generation sources, like solar panels, even after the main utility grid has lost power. This situation can be dangerous for utility workers and can damage equipment. To prevent this, there are strict compliance rules. The Institute of Electrical and Electronics Engineers Standard Number 1547 requires that distributed energy resources, such as photovoltaic inverters, must detect an islanding condition and disconnect from the grid within 2 seconds. This quick response is essential to ensure safety. There are 2 primary methods for detecting islanding. The first is passive detection, which monitors voltage and frequency. If these values go outside of set limits, the inverter will disconnect. The second method is active detection, where small disturbances are introduced into the grid. This helps to identify islanding situations more quickly. Grid-tied inverters must undergo factory testing to ensure they meet these anti-islanding requirements. This testing checks if the inverters can properly disconnect under specific voltage and frequency conditions. Utility companies often requiring these tests to approve the inverters for use. In some cases, regulations may requiring an additional independent anti-islanding device. This is especially true for medium and high voltage installations. Having this extra layer of protection ensures that if the inverter fails, there is still a safety mechanism in place. Utilities typically expect compliance with standards such as the Institute of Electrical and Electronics Engineers, Standard Number 1547, and Underwriters Laboratories, Standard Number 1741. Following these standards is crucial for safely connecting renewable energy systems to the electrical grid. Practical considerations also play a role in anti-islanding protection. The system must be able to handle complex grid environments with multiple energy sources and storage systems. The settings for these protections should be adjustable to accommodate changes in the grid and allow for maintenance without compromising safety. Inverters are designed to disconnect automatically during grid outages. However, some hybrid systems may have additional controls that allow them to power critical loads while still following compliance rules. Understanding these compliance rules for anti-islanding in grid-tied systems is essential for ensuring safety and reliability in renewable energy systems. By adhering to these guidelines, we can protect utility personnel, maintain power quality, and ensure the stable operation of our electrical grid.